Hello, everybody. So we are going to start now the next part, which is the energy balance or the conservation of energy equation. So we already covered the conservation of mass principle, and now we are going to go for the next one. The What we're going to do now is the same thing we did last time. We're going to start with the equations that we're going to use for defining the energy of the fluid, and then see how to put this in the uh, whole conservation of energy principle. So, starting from here, the conservation of energy is very well known principle. It states that energy can neither be created nor destroyed, but it can transform from one form to another. So, it's a very well known principle. We have gone through this before in the energy balance course. So it's not a new thing. It's only going to be different here from the way we translate this principle into equations. So this is the main difference between what we did in energy balance and what we are doing here. And the difference is going to be originally from the types of energy we are interested in. So in the energy balance, we were interested in more in the work, the heat, and the enthalpy, because these are the things that are more dominant in the energy balance on units. But in this case, we are more interested in, or in fluid dynamics, we are interested in the energy of flowing fluid that relates to the motion, not just the amount of energy. We are interested in the motion of the fluid, so we are more interested in the types of energy that relate to the motion, and uh, that the change of any one of these forms of energy led to change in the total fluid energy. So this is the criteria on which we are going to pick the types of energy we are going to deal with. These energy, or these forms of energy that we are interested in, are called mechanical energy. The mechanical energy is defined as any form of energy that can be converted to mechanical work. Mechanical work meaning rotating a shaft or doing any mechanical work. So any form of energy that can be converted to mechanical work completely and directly, and this is important, directly. So it's not something that will convert to another form then to mechanical energy. So it has to be directly converted from this form into mechanical energy, using an ideal mechanical device such as turbine or pump. So this is what we mean by mechanical energy. I'm going to revisit this definition again, but for now, this is what we or let's agree with this definition on mechanical energy. So the take-home message that for now is that the forms of energy we are interested in are the forms of energy that can convert into mechanical work um, directly. The forms of energy we're interested in that fall under the category of mechanical energy are the kinetic energy, which is half mu squared, the potential energy, which is mgz. Z is the height or the elevation, and these are two forms. The third form, which is form we mentioned before in the energy balance course, which is the flow work. The flow work is the work that is applied on the fluid or by the fluid due to the difference in pressure between 2 points. So the fluid is flowing from point 1 to point 2, and while it's going from here to there, there is pressure that pushes the fluid to go from this side to this side. So this pressure that pushes the fluid is applying work on the fluid, or energy on the fluid. So this is floor, what we call it PV. I already discussed it in details in the energy balance course. I am going to put a link to the video that discussed this point in details in the description of this video here. So you can revisit it if you need to refresh your information. So, anyways, these are the three forms of energy we are interested in. Of course, we didn't include the heat because the heat cannot be transferred into mechanical work directly. So you can convert the heat into, or use the heat to boil steam, and then the steam can be used to generate work. Of course, this is not a transformation of the heat into work. So when you heat the steam, you either increase its pressure or the velocity. So it's going to be one of these two forms. So that's why we call them mechanical uh, forms of mechanical energy. So if we have a fluid at any particular point, and that fluid, or we want to get the total energy of the fluid at this point, then the total energy can be expressed as the sum of these three forms. So it's PV plus half mu square plus mgz. So it's the sum of the flow work, mechanical energy, and potential energy and kinetic energy. The units of this mechanical work is in units of energy. It's going to be joule, for example. If you check the units, this is kilogram meter square per second square. So it's Newton meter, which is joule. So this is the total energy. This is the total energy. We can put it in terms of the specific energy, which is, or specific mechanical energy, which is the energy per unit mass. So if you divide this whole equation by m for rho v, it's going to be p over rho plus u square over 2 plus gz. So this is form that sometimes we like to use for the mechanical work. So this is the total energy of the fluid. Now there is one other thing here we can do using this equation, is that if we have a fluid or 2 points of the same fluid, and we fluid transferring from point 1 to point 2, so we can get the difference in energy between the 2 points, between point 1 and point 2, by subtracting the energy at point 2 minus energy at point 1. So it's P2 minus P1 over rho plus U2 square minus U1 square over 2 plus GZ2 minus Z1. This is the change or the difference in the mechanical energy. So this is the this is how we can define the energy of the fluid. Now let's go back to the previous slide and revisit the definition. So it's the form of energy that can be converted to mechanical work completely and directly. So I hope this part of the definition is clear. Now let's go to the next part, which is using or by an ideal mechanical device, such as ideal turbine or pump. So I want now to discuss what we mean by turbine and pump, or the mechanical devices in general. So a mechanical device is a device that can convert the mechanical work or the mechanical energy into work. This is simply what we mean by mechanical energy device. It's a device that can convert mechanical work or mechanical energy into work. Okay, into work. And the work is mainly, or the most common type of work that can be generated is rotation of a shaft. And this rotation of shaft can be converted to electricity or to whatever thing that we are interested in. So this is what we mean by mechanical energy devices. We have two types of devices that are very, very common. And these are, you can say that these are the two main categories under which most of the mechanical energy devices can be categorized. The first is a turbine, and the turbine is a device that is used to use the energy of a fluid that has high energy. So it's very common in dams and in it's like the wind turbines, or the windmills. It's like the turbines that are used in the water, or from that water coming from the dam, or from the waves of the sea. So it's any fluid that has high energy. So it's going with high velocity, or it's at high elevation, or it has high pressure. So a fluid with this energy, like a fluid at high elevation, can go here from up to down. It has very, very high potential energy. So this energy can be used to rotate the blades of a turbine. So it has like blades that can rotate, and this rotation can be transferred to a generator to generate electricity. So we are getting work out of this. Okay, so and based on this, the energy at point 1 before the turbine is higher than the energy after the turbine, because the fluid here has already lost some energy that was consumed by the turbine. So it's used to, the turbine is a device that is used to use the energy of the fluid or consume the energy of the fluid to generate power, mechanical work that can be used to generate power. And that's why delta E mechanical is less than zero. I mean, the pressure at point or the energy at point 4 minus energy at point 1 is negative. Okay. So this is the first type. The second type is the opposite, which is a pump. So a pump is a device that is used to provide energy or supply energy to the fluid so that it can transfer to further distances or to higher elevations. So, and we use it a lot at homes. In your home, you'll find that there is a pump that is used if you live at high second floor, third floor, or something. There is a pump that is needed to push the water and allowed to go to high floors. So this is a mechanical device that provides energy to a fluid and force it to flow. And of course, the energy after the flow is less. It's higher than the energy before the pump. The energy after the pump is higher than the energy before the pump because it's already gained energy from the pump, and that's why the delta mechanical energy is zero. So these are the what we call by the mechanical energy devices. So anyway, so these are the two devices we have. We are going to discuss in the next time the pumps and the turbines in more details and get more information about the differences, and then go for the energy balance equation. So I'll see you then, inshallah. Goodbye.